when we were trying to build the program, we're trying to put on some content that was operationally interesting. So this is a little bit more from the outside world, so probably less focused on ThaiNOG itself, but more to increase awareness of what else you need to do in the wider industry. So I want to look at the operational deployment part of RPKI rather than talking about route origin authorizations themselves. Now, the 5 regional registries, Internet Society through the Manners Initiative, and a lot of people around the world have been spending probably how many years now? 5, 6 years talking about route origin authorization. So we've kind of done that and done it and done it and done it. And if you don't know how to sign your ROAs now, go please talk to the fine people at APNIC downstairs who are sitting at their table looking very lonely. So if you have not signed your ROAs, in other words, if you have address space and you've not created a ROA for it, please go and do it. If you don't know how to do it, folks at APNIC will help you. So please get that done. I'm not going to talk about that because it's been done extensively. Do we have a laser pointer? Or is it one of you? I have a laser pointer, but it's in my room, which is not the best place. No, I just want the laser. Oh, it doesn't work. Okay, never mind. I'll just wave at the screen. So what I want to do is just quickly talk about how to make use of these ROAs that we spent so much time getting signed. Because there's one thing signing them, but then we're doing this for a purpose. And a lot of this is all part of Manners. I mentioned Manners just now. It stands for Mutually Agreed Norms for Routing Security. Got a nice logo and so forth. But the bits I'm worried about are these two: preventing propagation of incorrect routing information and facilitating validation of routing information. So these are actually really important. You remember Barry's keynote yesterday? You should be very afraid. Oh, he's on after me, hopefully making you, well, maybe not more afraid, but making you more aware of what needs to be done. So the 3 steps towards using RPKI every day: we need to get validators deployed. So these are devices that sit in your network that talk to your routers so that your routers know whether prefixes are valid or not. Second step is getting your routers to talk with the validators. So your external BGP speaking, so all the ones that are facing other networks, whether it's your upstream, the BGP customers, or your peers. And then the third step is making decisions about dropping invalid routes. Each step is significant. You want to do each one in turn. You don't want to just sort of set up a validator, bang, and off you go, dropping invalids. We did that in 2013 and 14 when this was all new. And we discovered a lot of things that didn't quite work as advertised. So we need to be a little bit more careful because this is a significant operational deployment decision. Okay, that hasn't worked so well. The table border has disappeared here. Typical ROA looks something like this. It's the prefix and the autonomous system that is originating it. And it's a digital signature, so you can know if a ROA exists that this is a true indication that this autonomous system can originate this prefix. So if another autonomous system originates the prefix, you know that there's something bad happening. Right, so we're going to look at the first step, validators. So this is based on just my general experience. So both working at NSRC with research and education networks, and my own experience working just with my own clients across the region. Looking at the validator caches, there are actually not many out there. The most popular one is the one by NLNet Labs, the Routinator 3000. It's a very easy install. You basically, if you're on Debian Ubuntu, it's apt install. There's not much more to it than that. I'm not going to talk about how to install them. You can go and read their documentation how to do it. If you're really keen, you can build it from source, but why bother when a package is available? Another popular one is Fort. This is by Nick Mexico. So again, packages are available. You can build it from source if you really want to do that. But these days, packages available, why bother? Then this one. So this one's interesting. They're in two pieces. One piece talks to the regional registries or all the CAs. That's RPKI client. So all it does is just gather the VRPs, as they're called, validated row payloads, from basically all the CAs, so the registries and a few others. And then there's stay router, which is the piece that talks to the router itself, or your router talks to it. So it uses the RPKI to router protocol. That's what RTR stands for. So this is actually quite neat because there are two pieces. With Routernator and Fort, there's just one piece of code running that does both things. And I'll say why in a minute. Right, so again, this is a little bit more challenging to build, I found, because it's kind of built for OpenBSD. And sorry, OpenBSD folks, but not many people use OpenBSD. Most, at least in this part of the world, is Ubuntu, Debian, or Red Hat family. But at least the folks who build this have got a port for the other more common OSs. Stay router itself, in theory, it uses the Go language. So in theory, if you can run Go on your thing, then it will run stay router. There are two others out there. I've not played with them at all. Folks are using them, obviously, because they're out there, but I've not looked at them. There are also some that are no longer maintained. If you have deployed RPKI using your network, please don't use these. They're not maintained. So you're probably better off looking at the first three that I mentioned. Right, installing a validator. So those are the three that are widely used. I've listed them in order of ease of installation. It's not order of recommendation. It's basically how easy I found to get up and running. And if you want to know about the details, I've documented them all on my website. So just trying to put hints and tips there. My advice, deploy at least 2 validator caches. Actually, given I've listed 3 common ones, probably just deploy 3. Geographical diversity is important. And also have 2 different implementations just for software independence and, let's say, standards interpretation. You would think if there's a standard defining how all the RPKI process is operating, that they would actually produce the same output. If only. Implement each on a Linux container so that the container can be moved around, and that's standard practice these days. If you're running dual stack network, configure them to listen both on v4 and v6. And also secure the validator. They listen to pretty much anything on a particular port, so make sure you secure it like you secure everything else. And then watch it. Just watch what it's doing, right? You're not getting this validator talking to your routers yet. Just watch what it's doing. Routernator is quite handy because it has a web interface. So you can actually have a look at the cache and see what's going on. RPKI client produces JSON output. If you can read JSON, then you can see what it's doing. But actually, you can look and see what's actually going on. Also check what the startup time is like. What I find is Routernator and Fort will sync the caches each time the process starts. So when you start them up, they spend a fair chunk of time talking to the CAs around the world and just getting the latest info. I find 15 to 20 minutes is quite normal. RPKI client and stay router are independent processes. RPKI client just runs every hour. You set it up to run every hour. So when stay router starts to talk to your router, it just uses the latest data that RPKI client has produced. So it's instantly ready and available. This makes me very happy. This one is kind of bothering. It does bother me a bit because you've got to wait. The routers have to wait until these two validators are operating. What about memory, CPU, physical storage? These all live inside a gig or two of RAM. I find certainly on Linux systems, one CPU is enough. The storage, 2.2 gigs, and growing because more and more people are signing ROAs. So this is only getting bigger and bigger. So don't put it on a tiny little container. Make enough space for it. Right, that was step one. Step two is getting the validator to talk to the router. This is significant because the router now is making changes into the BGP table, I suppose, and starting to make decisions potentially. So, setting up the validator itself doesn't have any operational impact. But once you have the router talking with the validator, it's got this extra table about all these BRPs. Only configure eBGP routers because they're the ones that are learning prefixes from the outside. I don't think there's anything to be gained by configuring iBGP to talk to the validators because you've already checked at the edge of your network whether a prefix is valid or not. So you're only going to get valids or ones that have no ROA inside your network. So trying to set up iBGP doesn't make any sense, to me anyway. But somebody will probably have a good reason for doing it. And of course, the validation information isn't propagated by iBGP. It's completely separate from the BGP process, although you can get implementations to do the propagation if you want. So just don't do it. It adds an extra level of headache that I'm not going to go through here. And then the scary one, the vendor defaults. The ideal behavior is that the router creates an internal validation database. And then the operator needs to implement some kind of policy so that BGP process uses that validation database. And so basically flagging what's valid, invalid, or not found. And then the operator also configures some policy what to do with these three states. That's our ideal process. And that's what the standards folks are really hoping for. Unfortunately, reality is totally different. Junos, Bird, and FR routing generally let you do this stuff. Cisco, unfortunately, does not, and still does not to this day. Configuring a validator on Cisco iOS, XE, or XR immediately turns on validation, the third step. We cannot do this middle one, not easily. It's very hard to turn off. We've been trying for a decade to get this fixed, but there doesn't seem to be much interest in Cisco in doing that, which is a great shame. So I've mentioned those four, but what does your implementation do? I mean, I don't know what Huawei or Nokia or Arista or all the others. There are lots of different vendors who support RPKI, but I don't know what they all do. But check what your implementation does. Whoops, went one too far. Did I go one too far? No, that was okay. Sorry, I did go one too far. How does your implementation react to changes in validation information? This was, well, I suppose it first came to light a good year ago. For example, if a route changes from invalid to valid or not found, what we found was that some implementations send a route refresh. But you know how a route refresh works in a router? It sends a request to the neighbor, send me the whole BGP table again. So if you get a full BGP feed from an upstream, for example, if validation information changes for one prefix, you say, hey neighbor, send me everything. And what we've found in some networks, and this was seen in some big networks, that the control plane of the peer router was running pretty much 100% because every time their neighbor had a change in validation information, they had to send the full BGP table. So it's really important not to rely on route refresh to implement changes. So again, some vendors do that, others do not. Basically, most implementations today maintain what's called AdRib-in, which is the BGP table before it actually lands in the active BGP rib. So some of you remember this from years ago, the Cisco iOS soft reconfiguration. And that predated route refresh. And it was a way of changing policy without actually shutting down BGP and bringing it up again. Of course, route refresh was invented or developed. And so we didn't use soft reconfiguration anymore. But unfortunately, on Cisco iOS and XE and XR, as far as I'm aware, validation information changes, Cisco routers will send a route refresh to appear. So the only fix at the moment is to turn on soft reconfiguration. So, but again, check your implementation, what it does. Does it maintain AdRib-in? So Juniper, for example, by default maintains an AdRib-in, which, well, again, I'm not telling vendors how to write the code, even though I used to work for one years ago, but maintaining this AdRib-in seems better. We don't want to rely on route refresh just to implement changes. If you're interested, there's an internet draft that, well, Randy Bush, Mark Tinker, K.R. Patel, and some Philip Smith chap wrote about all that. So just the general considerations. And here's why I was talking about the validators. Right? I implemented 3 validators. I used a Go router, which was the Cloudflare's now discontinued one, just to monitor the difference. And you'd think they would be the same. But RouterNet and RPKI clients are pretty close in what they do, but Fort shows significant differences. So which validator you use may determine what is marked as invalid or not. So you generally want to monitor what's going on. The third and final step is actually doing route origin validation, which is dropping invalid prefixes. That's where we want to get. So where do you start? And you look at many of the major operators who've done this. Some have started just with the BGP customers. Some have started just with peers. And transit providers probably ends up being the last one. You know, again, it's up to you. I tend to just say, we'll just do all eBGP right from the beginning. Depends how big your network is. I mean, if you're a global network, just doing everything in one big bang may not be the best idea. But you know, for a network in Thailand, you'll probably be able to apply this to all your eBGP sessions. So on Cisco, you have to remove the knob that automatically drops invalids. That was the knob. For everybody else, you just implement policy, design a policy that looks for invalids in the BGP table and drops them. Do you drop them inbound on the eBGP peer? You probably do that, but then you'll never get to see what the invalids are. And I'm kind of a curious person. I want to see what the invalids are in case customers come to me and say, hey, why can't I get to this website? So I tend to do them outbound on all BGP peers. So you see what the invalids are, but of course you never propagate them. Again, it's up to you how you do this. You also need to do a little bit of information dissemination. Tell your network operations center what's going on. Tell the customer support what's going on as well. I mean, this is hard-learned lessons from, well, route flap damping. Anybody remember what that was about? From like 1996? Barry's on next, he will. But, you know, we implemented route flap damping to stop a certain large US provider causing 100% CPU by BGP updates, but we didn't bother telling our customer support people. So you want to make sure that your operations, both customer facing and internal, are aware of what's going on. Keep an eye on path changes or traffic loads and external links. Things will be slightly different, more than likely. End users may observe connectivity or path change issues. So prefixes marked as invalid because the origin row was not set up properly. So, whereas the aggregate may have one, and there may be a subnet that's invalid, and therefore that path would have been the best path before until you started dropping invalids. So there are things like that you need to be aware of and keep an eye on. Finally, last slide, almost. So who needs to do this? Well, those who are interested in helping prevent the propagation of invalid routing information. Transit providers live in the default free zone, so you definitely need to do this. You provide transit to other autonomous systems, so you need to do ROV. Exchange points at the route servers, definitely. So BKNix here, for example, does ROV, which we did the last time I looked. You still do? Yes. Yep. So do that on the route servers. CDNs and cloud providers, absolutely as well. They're all connecting large numbers of peers. And you don't really want invalid routing information appearing within there because, again, of the content that they deliver. Access providers are usually multi-home to 2 or more upstreams and have a default route. The thing is, if you drop an invalid, routing falls back to the default route. So access, do you need to do it? Probably not. But you probably want to monitor the invalids anyway, just to see what's going on. And anyway, your upstream providers should be the ones who are doing ROV anyway. So this is very much more for those who are providing transit to other autonomous systems. So those are the 3 steps. Split them into 3. Don't try and do everything in one big rush. So setting up the validator first and watch them, see what they do. Get your routers talking to the validators, but don't drop invalids yet. And then the final step, the big one, is actually dropping the invalids. And be aware of the operational issues behind all this as well. And that is it. So I hope that was useful, interesting. It's a bit of an excerpt from the 3-day workshop that we're doing tomorrow. I kind of took one big presentation and condensed it into about 20 minutes. So just to share it more with you. So hope that was useful. Any questions? I think in the sake of time, ask me during lunch or the next 3 days.
Thank you very much, Philip, for your session. And the last speaker for today, we have Barry Greene, who is the keynote speaker for yesterday's session. Barry will give a talk on an impact security BCP. So, are you ready, Barry?
I'm all ready. Can you hear me okay?
Yes, I can hear you. Yep.
Outstanding. Very good. Let me go ahead and share my screen. That's the one we're going to share. Sure, move my video over and go into the slideshow here. So I'm understanding we're short for time, and I figured that. So my best common practice is reduced to just one thing. What I found is the one thing that is one of the most impactful security tools you can all subscribe to that will really help you with the risk reduction and security of your network. And believe me, I've been using this tool for years, and I'm a big supporter and use it even now inside Akamai. Akamai is a big user of this tool. So, and this tool is simple. Doesn't cost you any CapEx. It doesn't cost you any, subscribe to any security services. It's not one of the big fancy services. And you'll hear this thing called surface area security. Vendors will come to you and say, you need a surface area security tool. And you can look at them and says, I'm subscribed to the best one in the internet and it's free. And it does more than what you can offer me. And that's the tool, because you can get it via email and APIs and it's pulling things together. And that service is from Shadowserver. Shadowserver.org for the past 15 years has been providing a free reporting service to any organization that can validate that this is my network, that will go through and say, here are the scans, here's malware on your network, here's botnets, here's customers who are infected. It gives you all these tools. This link down here, and I sent over access so you can get access to these slides, will tell you more. So what does Shadowserver do? And this is different than, they just don't scan the internet. Some people will say, oh, well, they're just another scanner. Well, scanner is a small fraction of what they do, because they're connected to all the spam and phishing traps. They're doing malware analysis. They have, some people might have heard of virus totals, where a lot of virus totals malware samples come from Shadowserver, the malware binary sample and analytics tool. All the antivirus vendors collaborate on that tool. And when there's a new domain or a new host, like a host who's one of your customers, and that's being used and it's found in that tool, it's fed into the system. They have a huge honeynet system. They have feeds from law enforcement and takedowns. They are connected to the registrar of last resort. If you ever wondered what happens to a domain name when we take down a piece of malware, we actually have a registrar, a DNS registrar, registered with ICANN, that we park those and we monitor in the Shadowserver world, and we monitor if there's any hits. We see the computers that are actually trying to talk to it. That means that computer who's trying to talk to it is probably infected. And if it's on your network, you'll get a report, right? This is an old slide. It says 80 reports. We're up to 124 slides of reports potentially out there. So this is the sort of thing that goes into it. And then it goes out to all sorts of organizations. Like in Thailand, Thai CERT gets this report. They get a big aggregate report. Law enforcement gets reports. All of you can get the reports, right? So it's a powerful tool with it, with all this information going in, right? Scanning what's going on. It gives you an idea of what the bad guys can see on your network. So if you remember my keynote talk yesterday, one of the things that's being advised is for you to know what is on your network and where you are at risk. What can the bad guys see? How are they going to attack your network? The Shadowserver reports that come in daily will tell you that, right? So they'll tell you that. So let's go through, like, here's a whole bunch of different reports. This is also, I need to update that. It's not, like, again, it's 124 different reports. There's new reports happening all the time because new things are happening and the community works with Shadowserver to add these reports. And by the way, Shadowserver is a nonprofit. It's a nonprofit registered in Europe. It's a nonprofit registered in the United States. So it's all about public service, what the organization does, right? So each of the reports have details like this. They'll tell you, here's what the report does. Here's what the format of the field is. So when you get a CSV file delivered in your email, here's what's going on. There's an API tool now, right? So like inside Akamai used to have a tool that would take the emails and then parse it and process it. Now what we have is we use the API. So we take the API and we take the API tool and we create alarms. If we see this in this report, right, then we go out there and we have a process that we take and process the reports. So here's an example. This is a report I pulled in because I helped several organizations out there. Everybody here has routers. So if you want to start saying, are my routers vulnerable, right? First thing you look at, simple network management protocol. People say, oh, wow, simple network management protocol. But this is from a real network. In all these machines, it gave the IP address, the host name. Here's the actual details. You can see all the switches. Cisco, a lot of Cisco on this particular network. And the releases. Okay, think about this. If I'm a hacker, I want to break in, I look at the Cisco vulnerabilities coming out, and I look at the software version here, and I'll know what tool I can use, all right? So this is where it kind of gets dangerous, even the simple sort of tools out there. And when you look at the continued information in there, it will show you, here's the region, the city, right? SNMP version, which is simple network management 2, right? And then you get to the very end and it says, okay, what communities was used, public. So these are SNMP wide open to the internet with a public community that's readable. Okay, that's fun. This is where you go through and you get this report and say, these devices need to be locked down. They are vulnerable to attack, right? So how I've used these reports before, like at one telco I was at, what I would do is go through and I'd had two individuals. We didn't have a security department. We needed to do something. All I did is take the Shadowserver reports and had these two engineers, and they received reports, right? Now they had email, they didn't have API. Today, we created a little API tool, right? Then we don't try to do all of them, because when you first look at this, you're going to go, wow, this is all so infected. This is going to be nutty, right? So you don't try to, don't try to do everything. Just pick one or two, right? Pick several of them. And then you evaluate. Like a router that's open with SNMP probably is open to SSH, probably is open to other things, right? Probably doesn't have infrastructure access list set up, right? So the basic protections are probably not there. So you evaluate the risks and say, well, SNMP might mean that nobody deployed the infrastructure access list to protect the router. Okay, let's fix the infrastructure access list. That's going to fix SNMP and SSH and probably some of the things, the same device, the same switch on other reports. And I take action. Next day, new reports come in, pick some, take some action, right? That's the cost. The cost of Shadowserver is you finding some teams, and they don't have to be like you super security experts. This is a great entry-level engineering job. So if you bring in engineers and their job is going to be security and doing networking, you assign them to actually work the Shadowserver daily reports. They will learn so much. And they'll be going around the network learning things and actually reducing the risk to your network with it. That's what I advise, because that's what I did. I took two engineers that just hired out of college, right? So here's some examples that really helped me. So back in one organization I worked at, I came in the morning, I looked at my Shadowserver reports, and Mebroot popped up, 19 computers infected on Mebroot, right? Holy cow, right? This was, so that my network had 19 computers and were now trying to connect up to the Torpig botnet and infected with Mebroot. Mebroot was nasty, right? We don't see much of it out there, but it's a type of malware that actually you have to throw away the hard disk. You can't get it off the hard disk, right? So it's expensive. Immediately we pulled those 19 computers off, and we actually were able to fix it, and we saved so much money because we stopped the spread of Mebroot inside the network. It would have spread all over the place. And these are computers that were fully patched, up-to-date antivirus. And the way that Mebroot got in was through a 0-day vulnerability, right? So this report saved so much money in that particular incident. And there's many more incidents I've been involved with where that free report, it saved it, right? Again, the story I gave with two engineers coming out of college in Indonesia, put them on the work, and all they did is just crank through reports every day. And within 6 months, these two engineers were like super dudes. They really knew how to actually do troubleshooting on the network of finding security problems. And then I took and moved them to other parts of the network, promoted them, brought in two more interns as an entry-level position. This is one way you can actually handle these reports, right? We use these intensively for doing things like, for instance, the big carrier community. I mentioned yesterday that the industry has been pushing back on DDoS booters and stressors. Well, one of the tools we have is the Shadowserver tool that will allow us to go through and actually backtrace. We can backtrace to the source. When people say spoofed address, we can't trace it, that's false. When we take NetFlow or IPFix, combine it with Shadowserver data, and knowing what to look for, we can actually go from AS to AS to AS and find where the bad guys are spoofing, and BCP 38, source address validation is not working. And we'll go plug the hole, right? So this is a powerful tool out there that we use it up there. So how do you sign up? So being mindful of time. So here, how do you sign up? We got to, Shadowserver's got to know who you are. Name, organization, roles, right? You go to this URL, you say, get the reports, and you fill in the blanks. Then you add in all your autonomous system numbers, you add your CIDR blocks, you add your domain names. For an organization like Akamai, we have a lot of ASNs, we have a lot of CIDR blocks, we have a lot of domain names. We put them all in, right? If you're a national cert, which in Thailand would be Thai cert already gets these reports, right? And they get it for the country, then you actually interact with Shadowserver as a country level. And then they will get a series of reports so they can see what's going on with the country, right? And then you will be added to the access and an email list, right? And then you can add people. So you get a couple of people on, and then you can add people on your team to the email list so you can get these daily reports and set the API key up, right? Key thing with all this is you just can't say, just give me the reports. Shadowserver will do the due diligence to make sure they'll check the RPKI records, the CIDR blocks, to check the registration, to check the domain registration. They'll make sure that you are not pretending to be somebody who should not have access to this information, because it is a whole bunch of vulnerabilities that gets disclosed to you, right? So that's why Shadowserver takes a lot of interest in this. And the only thing that's shared with you is things that belong to you, right? You don't see the world, right? So if you're Network B, Network B's domain names, Network B's CIDRs, Network B's autonomous systems, that's what you get. You don't get anything more, right? So and Shadowserver also doesn't sell its data and doesn't give its data away. So your data isn't going anywhere, right? It's that this is part of the trust that's built up with Shadowserver as an organization for these free reports and why they're so successful, right? And as I mentioned, if for CCerts, Thailand already covered because Thai Cert is getting these reports with it. And if you want to see a longer version of this presentation, you go to my YouTube channel. There's a presentation I did for SGNOG. We're probably going to be doing an update version of it. And then yesterday, this is one of the other things I mentioned people, do sign up to get the reviews for the CERT team, because you'll get these issues coming out with, password hacks going into routers. Speaking of breaking into routers, one of the things I'm suspecting is the Russians who are breaking into and using poor password choices on routers, they're finding them with the SNMP. That's why it actually added in there. You can see my talk on that. So takeaway from here, sign up for Shadowserver. If you want to see more information about some of these reports, I'm going to be publishing more of them on my YouTube channel. So sign up for my YouTube channel. There's already like all the Apricot tutorial materials there, different NOG talks. This talk, I'll redo it and push it up there so you can use it with your teams to share the information. And again, you can sign up to my LinkedIn page, email me questions at any time. Philip and I, we love doing things like this. Philip was pointing fingers at me, I'll point fingers back at him. One of the things we enjoy is these human connections and networks. I wish I was there next year. I hope to come out and then, help Philip with some of his workshop materials. So thank you very much. I think everybody's waiting for a break. If there's any questions, you can email and thank you.
Yes, thank you, Barry. Any question from the floor? Yes, hopefully we can meet in person in Bangkok. So
yes,
I have one little question for and if I am the enterprise and I have not any S number, so I can subscribe to get the report.
You can, because you have IP addresses and you have domain names. So you would add those in there. So for instance, an enterprise, the value for the enterprise is if you put your domain names and you put your IP addresses, then they will, like malware and phishing and spam, they'll be spotting things like that and be able to do things like that with it. So enterprises are worthwhile. Like a lot of banking institutions and financials, they're starting to subscribe to the Shadowserver report.
That's good. That's good. But anyway, if I use the IP from the ISP, is it possible to use the IP from the ISP?
So what will happen is Shadowserver will go and look, and if your ISP has SWIFT, right, where they've allocated an address to you and registered that with APNIC, right, then that works. So what you do with an enterprise is you check with the ISP. It says, hey, have you documented that you allocated this /24 to me? Right. And you go to ISP and make sure they've done that, work with APNIC. And those of you who are sitting there, if you don't know how to swip the address, well, APNIC is sitting down there at the table. You can go ask them and they'll help you register that. So that way your enterprises can sign up the reports like this.